Hello, everybody. Welcome to our very first CTI 140 Virtualization Concepts live stream class. I see a couple people, looks like, have joined me here in the live stream, and that's pretty cool. Thank you all for coming. Hey, Jacob. See, it all works. Look at that. So I'd like to try to, this is something I'm trying this semester, trying it for the first time. Going through and just doing some class type stuff. Probably won't take very long in these classes, maybe 30 minutes ish. Just give you the rundown as to what we're doing. So we're going to go through a few slides, and then we'll let you go about your day. So this is our very first live class. So today, these are the things that we're going to cover. We're going to describe virtualization. We're going to talk about the three properties as outlined by Popek and Goldberg, and we'll get into what that means in just a moment. We're going to understand the two key trends that drove virtualization. Hey, Jorge. And we're going to understand why virtualization is a key technology in the data center. So we're just going to go through a few different few slides here and talk about a few different things to kind of introduce ourselves to some virtualization concepts. So in Module 1, we're kind of addressing this question in general, and we're going to talk about it just for a few minutes here. So when we're talking about what is virtualization, we're essentially talking about abstracting a resource. So we have hardware, we have something physical, right? And we want to take that something physical and we want to turn it into something logical. We want to turn it into something that's, hardware into something that's kind of software-based. So when we're talking about virtualization, that's essentially what we're talking about. So we're taking physical servers, we're taking physical hardware and we're turning them into virtual machines. But to the users, to you and me, people on the other end that are actually getting a hold of these things, that are using these things, they look and they act exactly like they always have. And we kind of look at this as a new model of resource utilization, but as we'll talk about in just a moment, virtualization isn't a new thing. We've been virtualizing machines for, 70 years now, or better. But essentially what we want to do is we want to take and we want to put something in between our hardware so we can give it kind of multiple uses. And that's what we'll be doing, when we get into the next module, we'll actually start using some hypervisors to make some virtual machines, and that's what we'll be doing. Hi, Vince. And we'll be working to make some virtual machines on our desktops. So that's kind of what we'll be doing. And when you think about virtualization that way, we're taking a physical resource and we're abstracting it into something logical, into code essentially, because we can use it for many different purposes. So virtualization isn't new, like I just said. We started utilizing mainframe virtualization back in the 1960s. If you'll remember back to any kind of like computer history class you've ever taken, when you worked back in mainframe computing, you had one computer, and that was a massive mainframe computer, and that one computer could do one job. So in the 1960s, they kind of came up with the idea of virtualization. They said, what if we could kind of put something in the middle, this virtual machine. Back in those days, they called them virtual machine monitors. We have a different name for them today. But what if we could put something in the middle to where we could take this big mainframe, this big piece of hardware that can only do really one thing at one time, and virtualize it so where we can run different programs on it without having to do big changes to it. So we were doing mainframe virtualization back in the 1960s. When we look at like virtualization in the data centers and virtualizing servers and doing like infrastructure as a service, that sort of thing today, a lot of the stuff that we look at, we think about that as like a new invention, but we were doing that, back 60 years ago. And it was really codified in the 1970s by Gerald Popek and Robert Goldberg. And they gave 3 properties to virtualization, what a virtualized environment should be. They said a virtualized environment should have fidelity, it should be isolatable, or it should have safety, and it should be performant, or it should have good performance. Yeah, in looking quickly at the chat, Jacob's pretty much right on the money. With the answer to your question, Jonathan. So with a virtual machine, I'm essentially just using my hardware, and I can build on top of it any kind of machine that I want to build on top of it, and I can, have what we now call a hypervisor, what we called back here in the 70s a virtual machine monitor. That's kind of the go-between between our hardware and our environment. So, really, what we're getting into here is kind of the answer to your question. It kind of gets into Popek and Goldberg's 3 properties: the fidelity, the isolation, and the performance. So a virtual environment should be identical to the physical. So I should be able to put a virtual environment on my physical hardware, and it should be able to run like my physical hardware runs. So when you get onto that machine, you should be able to tell no difference between a machine with that directly installed on it and a machine with the virtualized properties on it. Another thing is that it's isolatable. So the VM must have control of the system resources. So when I'm in a virtual machine, that virtual machine is kind of sandboxed. It's isolated onto itself. So whatever I do in that virtual machine isn't going to impact the host machine or any other virtual machines. It's in control of its own system resources, and it's isolated unto itself. And then performance, little to no difference in performance, kind of relates back to fidelity. They're more or less similar in that regard. Identical to the physical environment in how they perform, and identical to the physical environment in how they do all the other stuff, process information, everything else. So an efficient virtual machine monitor has all 3 of these properties: fidelity, isolation or safety, Can you elaborate on that question? I'm not entirely sure what you mean by that question, Jonathan. If you could elaborate on it just a little bit. I mean, Jacob is correct. I mean, there are some ways that it can tell, like when you're virtualizing interfaces to emulate hardware. He's right with that. However, if you have it set up in such a way where you're using the hardware the way it's in a perfectly efficient virtual machine monitor type of system, for a perfectly efficient virtualized system, you shouldn't see much of a difference. Right. Yes. Yeah, that's accurate, Jacob. Yeah, so then you can run code based off of that to run differently if you can recognize virtual hardware within your operating system. All right, so an efficient VMM, virtual machine monitor, has all three of these properties as codified by Popek and Goldberg. Looks something like this. So we have our virtual machine monitor, which we now call a hypervisor. That sits on a layer in between the physical server or the host. Now, for our purposes, we're doing a lot of desktop virtualization. So our host is going to be, in general, our computers, your own personal computers. You got your hypervisor that sits between that. That's the one that's going to do all the virtualizing work. And in that's where you build your virtual machine. And on your virtual machine, you install your operating system just like you were installing it on a brand new computer. And when we get into the next module, you'll have your opportunity to do that for the first time with VirtualBox. Even though it seems like a lot of you have had some experience with virtualization already. So for those of you who have, it should be incredibly easy for you. But with a general layout of what we're looking at for a virtual machine, how everything kind of interplays with one another, this is what we're looking at. Something like this right here. We have our virtual machines which live in our layer of a hypervisor, which are the hypervisors, the thing that actually goes between our physical hardware and our virtual machines. So in terms of the history of virtualization, we can look at this a little further. Companies began using technology to achieve competitive advantages and save money in the 1970s. So what they found were that proprietary solutions were expensive and inflexible. So naturally, that provided a means for a more generalized platform to come in and take a place in the enterprise market. Because, when we're talking about proprietary solutions, we're talking about individualized softwares, running on individualized virtualized machines at individualized companies. So you'd have to have one developed for everything, and that drives cost up. So Windows provided commodity platforms that started to drive costs down. And so since it's Windows, that also gets rid of that platform lock-in. Windows coming into the marketplace, we have more people developing for Windows. It's a more generalized system. So then providing these commodity platforms for enterprise allow businesses to get these things, put machines on them, and do work that way so we can lower costs. But, we're still looking at the 1980s here. So we're still fairly limited in what we could do. So we're looking at a one server, one application type of policy. So you've still got something similar to what you saw in the 60s and 70s with mainframes, just now it's a little cheaper to do. But, as with most things in technology, we can apply Moore's Law to it. Moore's Law in general states that processing power doubles roughly every 18 months. Or at least that's how it was originally coined. This idea came from Gordon Moore. Saw the move from vacuum tubes to transistors, and now to the dense integrated circuit. With the rise in transistor density, we saw the increase in processing power. And so processing power doubles roughly every 18 months, and subsequently it got a lot cheaper. So that's how Moore's Law originated. Now we can apply it to a lot of today's technologies. We could apply it to pretty much everything that we see. In recent years, there's been some concerns with kind of Moore's Law slowing down. There's been some fear that we've kind of, hit a plateau in terms of where we can go by means of what we've got and what we're able to do. So it seems like Moore's law might be slowing down a little bit. But nonetheless, it still kind of applies. We're still moving forward in technology roughly every 18 months to 2 years. Things are getting faster. Things are getting cheaper. And with hardware getting faster and hardware getting cheaper, it makes our ability to virtualize them even better. So we got all those Windows servers from a couple slides ago. Windows moving into the enterprise market, taking control from the proprietary systems of old, more generalized things. One server, one application. Windows Server growth drove data center growth. And then data center growth drove resource utilization. So with more Windows servers, we had more Windows servers in one place, so we needed data centers. Now that we had data centers, well, we need resources to run those data centers. So that includes power, that includes cooling, that includes cable, that includes a place to put it all, square footage. That includes people to manage it all, the staff. That includes security, people to watch it all. Because, you know, if any of you have taken any of the mission critical stuff, or if you've had any of the mission critical material in any of your classes, you'll know that a lot of the data centers have some information that needs to be secured 24/7. That is cybersecurity, but that's also physical security. So we still had that one application, one server deal. We haven't quite virtualized our servers yet, our data centers yet. So Moore's law, with time, servers became more powerful, but less efficient because of application deployment practices. We still had that one application per server deal. So I probably could have done a bit of a better job. You know, like if it's a web server, that's what we have on the server. If it's a file server, that's what we have on the server. So we have to figure out a way to take these servers and make them more efficient through virtualization so that we can actually use these servers in different ways. Use one server in multiple ways, essentially, by virtualizing them. So in terms of trends that accelerate virtualization, we ended up with consolidation. What consolidation is essentially running multiple workloads on a single host. The consolidation ratio that we have there, that means the consolidation ratio is the number of virtual servers that can run on each physical host machine. So as hardware improves, our consolidation ratio gets better because we can run more virtual servers on our physical host server. We also have containment, deploying new applications in a virtual infrastructure, which also leads to a virtualization first policy. So instead of just deploying something on a regular server, we're going to choose to try to virtualize it first. We have this trend in the marketplace that says, we're going to try to virtualize this appliance first. Because we can make better use of our hardware, better use of our software. We can make better use of, we can make a more efficient use of the servers that we have. And we can have a safer environment if we know how to deploy these things properly. So if we virtualize it and move from there, then we can work that out. So what we see in virtualization during this time period is that it moves from an infrastructure enhancer, something that merely just, makes our infrastructure more efficient, to a business enabler. Because it's making our infrastructure better, more efficient, but at the same time, our businesses are able to run more things, able to do more things, based on the fact that our infrastructure is more efficient. So it's those efficiencies that help push us forward. So why virtualization matters. Hypervisors allow multiple virtual servers to run on a single host. In this way, future servers are used and resources are consumed more efficiently. I normally don't like to read directly from the slide. I like to kind of get the gist of it and read a little bit. But I can't really think of a better way to put that. More virtual servers, less physical servers, resources consumed more efficiently. That's a win all around. So we're also looking at a large return on investment by taking cost out of the equation of the infrastructure. So if we're running more virtual servers, we're taking out those physical servers, so there's less physical infrastructure. So those virtual servers running more efficiently are giving you a much higher return on investment than the physical servers that would be running in a less efficient manner. They're not just servers, but desktops and different applications can be virtualized. And that's actually the majority of what we're going to be doing in this course is desktop virtualization. And just as a little tidbit, we have the first commercial x86 hypervisor was VMware. And we'll be working with some VMware hypervisors later in the course. We start out with VirtualBox, which is Oracle. And then we move from there into some VMware hypervisors. And so that leads me to the summary of week 1, chapter 1, whatever you want to call it. So virtualization optimizes resource usage. We saw the 3 properties from Popek and Goldberg that were the big things for the creation of virtual machines and virtual machine monitors. We saw these 3 elements: fidelity, isolation, and performance when we were looking at an efficient virtual machine monitor. An efficient virtual machine monitor should have all 3 of those elements. Moore's Law and the spread of Microsoft Windows were some of the first things that allowed us to propagate virtual machines. And then data center virtualization drives down costs, drives better resource efficiencies, and is the platform for the cloud. So, because of this, we get things like infrastructure as a service, platform as a service, all those as a service things that you hear so much about these days. Cloud infrastructure in general. Virtualization helps us to drive the cloud because it's helping us make effective use of that server hardware. So that's all I've got for you today. I don't want these to last a long time. You know, I don't really foresee these lasting any longer than about 30 minutes because I know, you guys are all busy and you've got a lot of stuff to do. So if you've got questions, you want to hang out in the chat for a minute, I'm going to turn the music back on and I'll answer questions in the chat. Otherwise, that's all I've got for you. Have a good day. Thank you for coming, and I'll see you next time.